It's recording. We're going.
We're going?
We're out here.
I don't know if the mic.
So there's two masses supported by a string on a frictionless and massless pulley. So our job for this problem is to determine, first to draw a free body diagram, determine the magnitude and direction of the acceleration, and to determine the tension force in the string. So part A, we have our free body diagram. So this is mass 1. We have the tension force coming up, and then we have force of gravity. And this one is mass 2. We have an equivalent tension force coming up, and then a smaller force of gravity coming down. Because mass 2 is smaller, I should probably include what the masses of mass 1 and mass 2 are. It's probably a good idea. Mass 1 is 0.8 kilograms. 2 is 0.3 kilograms. There we go. Now everyone knows what's going on. So because mass 1 is heavier, the force of gravity is stronger. The gravity is still 9.8 meters per second squared, but because there's more mass, the force that's being applied, the downward force, is stronger on mass 1 than it is on mass 2. So that's why we have the difference in the two free body diagrams. So you have two equations to solve for the tension in the string based on the two masses. So the acceleration for mass 1 is negative because it's moving this direction. So it's accelerating downwards, which means it has a negative acceleration. Meanwhile, the acceleration for mass 2 is positive because it accelerates upwards. So it has a positive acceleration. So that's where this discrepancy comes from. Yeah, if you substitute them, then you get M1. So you get that. And then you want to bring all of the equivalent terms to the same side. And then you would pull out the like terms. So you'd have G times M1 minus M2 equals A times M1 plus M2. And then, so we're solving for the acceleration here. So we basically just divide this over. So we would have A is that the same equation? That's the exact same equation. Hell yeah, we're doing great. This is good. All right, so this is the equation for acceleration that you get. So basically you're just starting by assuming that the tension forces are equal. And then since they're equal, you can set these two sides of the equations equal to each other. And then you basically just simplify all the way down until you get just acceleration by itself on one side. And that gives you the equation that you need to solve for the acceleration. So let's just plug in a bunch of numbers to find out what the actual acceleration is. Is it kilograms? No, it's meters per second squared. I'm dumb. It's acceleration. Meters. Yeah, because the is kilograms. Yeah, those cancel out. Yeah, okay. So then you end up with this. There. That's the acceleration. The only difference between the two is that for mass 1, it's a negative acceleration, and for mass 2, it's a positive acceleration. So they have equivalent accelerations in terms of magnitude, but their directions are opposite. Cool. So C is finding the tension force. So you're basically just going to plug in values for the different masses into these equations that we found up here, or that we started with up here. Because the tension forces are equal, you can do it in either equation. You'll get the same answer. So I'm just going to do it with this one here because it has a positive acceleration, so it'll just make things a little bit easier. I'm not going to include the units because there's not a lot of room, so we're just going to do 0.3, 9.8. There you go. Ignore the fact that it's running into that equation. And if you put that into a calculator, which we did, you get 4.28 newtons of force. So that number is equal for both of the masses here. That's why their tension forces. Should probably label those. Let's label them like 4 minutes later. So force of tension. Yeah. So those two are equal. They're both positive and they're both the same value. And this is the value for those right here. So yeah, we have free body diagram, acceleration, and tension force.